In this video, we're going to talk about mole to mass conversions and also how to calculate molar mass. So remember relative atomic mass we talked about back in chapter 4? The AMU, or the atomic mass unit, was 1/12 the mass of a carbon-12 atom. But since the mole is the number of atoms in 12 grams of carbon-12, the decimal numbers on the periodic table is also the mass of 1 mole of the atoms in grams. So the gram atomic mass equals the mass of 1 mole of an element in grams off the periodic table. So 12.01 grams of carbon has the same number of pieces, in this case atoms, as 1.008 grams of hydrogen. That means if you weighed out about 12 grams of carbon and 1 gram of hydrogen, and you counted the number of atoms in each, it would be the same. It would be Avogadro's number of atoms. So this is really convenient because we can now count things by weighing them. So let's do some example problems here. How much would 2.34 moles of carbon weigh? So always start with what they give you, 2.34 moles of carbon. And then we're going to set up a conversion factor here. 1 mole of carbon is going to go on the bottom because I want moles and moles to cross off, but I want grams of carbon to be on the top. So you need to know how many grams of carbon there are in 1 mole of carbon. Well, that's easy. If it's carbon, we can just go to the periodic table and look for its atomic mass in the upper left-hand corner. Now we have a decimal number here. Now you could use that. That's perfectly fine, but it's also acceptable to round to the nearest whole number. So I'm going to just round down to 12. So 2.34 times 12, we'll cross off the moles and moles of carbon and be left with grams, which is what the question's asking us for. So I just need to multiply these, 2.34 times 12, and that would be 28.08 grams of carbon. How about how many moles of magnesium is 24.31 grams of magnesium? So we start with what they give us, 24.31 grams of magnesium, and we set up a conversion factor. To find the number of grams in 1 mole of magnesium, we just need to go to the periodic table. Magnesium's element 12, and if we find its mass in the lower left-hand corner, or in our case, on your table, the upper left-hand corner, it would be 24.305, and we can round down to 24. So that's the number of grams in 1 mole right off the periodic table. So grams of magnesium and grams of magnesium will cancel and we'll be left with moles. So our problem is 12.31 or 24.31 rather, divided by 24. It's going to be about 1.01 moles of magnesium. So what about compounds? So if we had a compound like water, H2O, and 1 mole of H2O molecules, there's 2 moles of hydrogen atoms and 1 mole of oxygen atoms. Remember, think of a compound like a molar ratio. It's basically the recipe of the number of atoms that make up that molecule. But if I had a mole of that molecule, it's the recipe of the moles of atoms that make up that molecule. So to find the mass of 1 mole of any compound, all you need to do is determine the number of moles of the elements present and multiply that number times their mass that you get right off the periodic table, and then add them up for the total mass. So let's calculate the formula mass for magnesium carbonate, MgCO3. So we find magnesium, which weighs about 24.3 I'm writing on mine. I have a mole of carbon. Carbon weighs about 12. And I have 3 moles of oxygen. That little 3 after the oxygen means I have 3 oxygen. So oxygen weighs about 16. So 3 times 16. So 24.3 plus 12 plus 3 times 16 is 84.3 grams per mole of magnesium carbonate. So the masses on the periodic table can be used 2 different ways. We can consider them as atomic mass units if we're looking at very small things, like on the atomic level. Or we can look at them as molar masses, the masses in grams of 1 mole of that substance. And we can use these molar masses to construct conversion factors to convert from moles to grams or vice versa. If you're dealing with an element, you just need to look up the mass value on the periodic table and use it in your conversion factor. But if you're dealing with a compound, the molar mass is the combined mass of all the elements in that compound. This is something we're going to practice a lot. This is important for not only this chapter, but in other chapters to come. You need to reliably be able to look up the masses, the molar masses of compounds, to do all sorts of math problems later on in this course. If you have any questions or need any help with this, please let me know.